thank you, Tran, for the very interesting stuff on the 3D. My purpose here today was to tell you a little bit about tomorrow, and maybe even more so a little bit about what we've done the last 2 or 3 previous days. We arranged the workshop to show you some potential for what we might be able to do with the NHERI equipment, the UT site, and how it could be applied to potentially imaging anomalies. Taking advantage of the fact that they were here for a week, we wanted to be able to utilize the equipment to maybe help you all, including Tran, get a next data set for his 3D imaging technique. So what we wanted to do at this test site that we have locally was to collect some data that might be the second and third chance for him to try out the 3D imaging on a real data set. So the Newberry test site, I refer to it as. Let me say a few more words. Go ahead. Thank you. Where this all started, of course, the Newberry test site, the first couple slides here was that my friend and I from Nick Hoodema, who's a professor of geotech at the University of North Florida in Jacksonville, and I became involved with the FDOT in the beginnings of our days here in Florida, dealing with the fact that they have sinkhole problems. We heard from the guys who are out there in the field here regularly, characterizing Karst terrain for infrastructure problems. And when we first started, they were dealing with all the problems they have in these dry retention basins that are all over the place. And they're out there, and every time you get a big rainstorm, you get a pile of these little sinkholes all over these detention ponds. And so instead of having the detention pond filter the water from all your runoff through the natural material, they're essentially going down a pipe when you have all these holes in there. So it's one of the issues for them about the stormwater runoff and the sinkhole problem they have in detention basins. So that's sort of how this all started for Nick and I a number of years ago. And of course they're interested, the DOT generally, in how might we detect sinkholes, not only under I-75 and for other problems, but certainly in these detention ponds as well. So we initially got involved with them in the detention pond area with a number of different types of techniques for finding them, and also they've done a lot of work in techniques for, well, if you have one where there's chimneys all over these detention ponds after a big rainstorm, how do you fix them? And so they've done a work in how to do that. So we've been playing a little bit of part of this larger effort, of course. Okay, Robert. So this particular site, Newberry, Florida, is a detention pond site near west of Gainesville. It's about 15 miles, and I'm going to show you on Google here in just a second. And it initially started as a site in which we were going to go out and try geophysical techniques and other things to see if we can find anomalies, and use in the potential back up, please, in the potential detection of where sinkholes might be forming. And then we've done a number of things at this site, site mapping. We've done all kinds of geophysical testing. We've done all kinds of intrusive testing. And it generally is a similar profile to what Tran had been showing us around this area. It's a mixed sand and clay over limestone bedrock. And in this particular case, the limestone bedrock is relatively shallow. In fact, it's literally outcrops on one edge of the field, and in as much as, it's only about 25 to 30 feet on the deepest parts of this site. So it's relatively shallow. And so our early work was on, can we find anomalies on this site? Well, it's turned out over the last dozen years, this is my playground, and it's Nick's playground as well. Every time we get a new piece of equipment, every time we get a new idea we want to try, every time we have a thesis we want some data for, every time I just am really tired of the office and I want to go outside and do something, I go out to the Newberry site. And we've used this for all kinds of things. We got a site somewhere else, and we got to get the dust off a particular piece of equipment, make sure it's working. We go out to Newberry. So we've done all kinds of stuff out there at this site. And so when Ken and Mung approached me last spring about potentially doing what, I said, yeah, I know where to go. I mean, we've been going out there for years, and we have a pretty decent idea of what might be going on. So continue, please. And we, as I said, we've done a number of things, many types of geophysical testing, seismic waves, GPR, electromagnetics, resistivity. We've done all kinds of intrusive testing. My friend Nick is really a rock mechanics guy, so we've taken cores from all over this place, and he does a lot of he's got several NSF projects funded on dealing with these weak, problematic rocks that we have here and ways of characterizing them and coming up with design parameters. So we have a pretty good feel for this, for a lot of the things going on at the site. Please, next. Anyway, so we wanted an opportunity, so we had the opportunity for the shakers here in town, and we knew Tran needed some data sets. So we said, well, what can we do to try something with a shaker as opposed to Tran's impact device? And so we put together a little plan a few months ago and went out and implemented it here this past week. Forgive my hand sketch here, but this was from yesterday, yesterday's testing and Tuesday's testing. So here is the site in Newberry, Florida. It's a pretty large dry detention pond. That width here is about 250 feet or so, and this is whatever that is, depending on the angle, of course. And when we first gridded out this site, we, again, about 250 feet across on the bottom, our 0 point was down here in the bottom left-hand corner, and we laid out lines at 10-foot intervals all the way across the site, and we call them A through Z, okay, for nothing better. And then we have station lines in the north-south direction starting from here, 0 to 400. Okay, so in the last 2 days, we've collected 2 data sets on the site according to these grid patterns right here. And these are similar grid patterns to what Tran showed on his data sets from the other site. Now, why did we pick these particular 2 in a little bit more detail about how we did the testing? Tran showed you his results on the 2D imaging a while ago, a couple slides ago, where he went and he did 10 parallel lines from lines K through T, and he found potential goofiness, anomalies down here on line P and line Q. And in fact, on his 2D images, his line Q hole void was right there. So what we decided is let's go out and collect the data set with the UT equipment, basically over the top of where we found this void about 5-6 years ago. Now, we weren't sure it's still there or not, because a lot of stuff changes out there. It could, but we want. Could it even fill in? Well, it could have caved in and it could have been repaired. But we saw no signs of it having been repaired. No, I don't think so. Because in fact, when I went out to lay it out, in fact, right there's a chimney. It's this big around, just a short distance from where he saw the void 5 years ago. It's only this big around, but I put a 10-foot orientation rod in the hole, and I couldn't find the bottom. You told him the answer? Well, we wanted it. We wanted. We wanted to do it over the top of where we had the suspicion of a void. Okay, so we did a grid like he talked about. We did 12 geophones, 4 wide, and we did 48 geophones in a grid, and we did a shot line of 13 by 5. And at each of those locations, we put thumper and ran let's see, an 8 to 80 hertz chirp. And we did that for this set of data. And then we did a similar thing down here. Now, if Robert, if you could go one more ahead. Here's the first one, and this is the grid we talked about. This is where we thought we saw the void from his 2D image from several years ago. This is where we know there's a chimney sticking out. We wanted to know that because we really didn't want to drive the truck in there, you know. So we were trying to be careful. And the first thing we did when I brought Mung to the site is I said, Mung, there's a hole right there. You tell me how comfortable you are going near that thing, okay?
I just want to tell you, Mung is not known as our best driver.
Well, Robert did a wonderful job. So anyway, again, here's the data Tran showed you a little bit ago. This was the motivation for why we picked this particular location and ran this array. Here's Thumper out at the site. The void, you know, in the trailer is the equipment that. So we did this on Tuesday. Collected this grid. Back one side briefly, and let's see. Do I have anything more to say about this? No. So again, as I say, we did 65 shot points, the solid circles there, into 48 geophones. These are all at. These are 10 feet on a square. So the spacing between the geophones is 10 feet, or about 3 meters, and the spacing between the shot points, again, about 3 meters. So every solid dot you see here, every solid dot here. So 65 shaking points, 65 shaking points into. So we collected the data from each of those 48 geophones 65 times. We did. It took us what, 4 hours to do the shaking. 4 hours to do the shaking, about an hour. Yeah, and right, that's true. One of the things in adjusting the array, there's some trees on the site, and there's some spots in there that are some loose sand, and we got a little bogged down here and there. So that kind of maneuvering slowed us down. But it took us about 11 till 3 to collect that data set after setting up in the morning. So 4 hours to collect that set of data. Again, 8 to 80 hertz chirp. 12. These were 4.5 hertz geophones. 4.5 hertz geophones. 4.5 hertz. Brady's.
Did you do anything special to couple the phone to the ground?
They're spiked in. They're on spikes right up into the ground. Nothing unusual that we wouldn't commonly do.
And how many? So you did a chirp, but how many times?
We did three averages. We collected the first one and then the average of the three. And Mung and I looked at these. I mean, the reality is you couldn't tell the difference. So, I mean, you know how you do this in the field. You look at one and you see a couple and you say, that's just not changing. I'm done. Okay, I'm not going to keep stacking unless it appears like it's making an improvement. In fact, I think we could have done one. Right, we could have gotten away with one. In my experience, I would have lived with one if this was a more production job. I had no problem taking one. It was very, very, very clean. The signals were.
He didn't say that he'd only take one for Florida DOT.
I would take as many as it takes to be comfortable with the data set, right? And if it takes 50, it takes 50. But in this case, the records were very clean. I mean, the amplitudes, even at these farthest distances, were, even with these 4.5 hertz, 50 millivolts or something, and the noise was, we had plenty of amplitude. And we had 2 volts on some of the nearby. So we got pretty good records, I think. Except one noisy channel that we just couldn't get rid of, right? Yeah, that's right. And I have the same trouble. Those seismic cables are noisy, typically. They're noisy, typically. Yeah. Yeah. So anyway, this was the line Q that was motivated by Tran's earlier work, and it was the first one we wanted to do. And
so are you Q? That's James Bond.
That's his equipment specialist, isn't it? Q was the equipment specialist. M was the boss. M is the boss, and Q was the equipment specialist. Yeah. So anyway, that was the line we did on Tuesday, and we weren't sure how long this was going to take, and so we were done. We said, well, we got a whole nother day. What are we going to do next? We got a whole, what are we going to do next? So,
he told me he took Wednesday off.
No. There's no way. I'm not going to do, I mean, geez. I got a shaker here for the weekend. I mean, yeah. And three more guys showed up yesterday. I mean, I was already doing nothing because these guys worked hard. So, anyway, could you go back a couple of slides to my main one? Yeah, there. Okay, so this was one we did on Tuesday, the first line. And I said, well, what are we going to do next? Well, we went down here into this corner of the site, which is over here, and we repeated the same type of measurements. And well, why is that? If you could go, there we go, thank you. So we did a similar type of thing, same type of a grid, shot 65 shot points into those 48 geophones. By the way, this particular spot, there's a chimney right there. Turns out, I don't know all the details, but this particular place in the site was motivated by much of the geophysics work we had done at this site in the past. A number of years ago, we had run lines all the way down this detention pond at, I forget what foot intervals, doing seismic refraction waveform tomography, our predecessor to full waveform, if you will. And when we did all those seismic refraction tomography lines, this part of the site was the most interesting. It was the most interesting because it was very non-uniform. Some of the other areas in the site, we were getting similar things along the line, but this particular so-called A line, we found these are 2 tomograms that you can take this one and add it onto the end. So we could, with a sledgehammer, you can't do a line more than about 100 and some feet, so we would just line them up because we can't get a good arrival after that. So anyway, there was a lot of variability in the profile, in these refraction tomography profiles along this particular location. And we put, based upon the refraction, we went back and did CPT tests years ago and found that the rock was all the way from here to, in some places, right there. Highly variable along that line. And following that particular location over the years, we had monitored, and there were at least, I have one tomogram, but there's a couple more that we had on there. We had at least three sinkholes appear right along this location, and they turned out to be here, here, and in this one right there where we had the boring.
Did he say that he just can create sinkholes? I think he did.
I don't know. I don't know.
He did. I don't know either.
But interesting.
Smartman did.
Maybe he did. Maybe. Interestingly enough, though, the sinkholes weren't right there. The sinkholes were on the top of one of these outcrops. They were in these bowls, if you will, where the lower velocities were. That might suggest some sort of a fracture zone or something. But again, this is first arrival tomography, so you can't see too many details. But anyway, that's why I was interested. So we went to the site and we did another array yesterday at that particular location. And it turns out, as I said, there's a chimney there as well. And yeah, Mung did some sampling the other day, and he found that there's a couple of chimneys right here as well. literally, right inside. The grass is a little tall there, and so he was wandering along eating his lunch or something, and right down the hole he went.
He can also find snakes.
Oh, really?
Yeah, and then he does
plenty of experience
as well. Yeah.
Okay. Okay, so. One more. I think I have one more just to give you a feel. This is an old slide from years ago, but the rock conditions at this place are highly variable. These are both from the A line, where that deep borehole, that deep place where we found the rock in that zone. This is the kind of intact rock you have at 10 meters or so at the site. Very nice material, very strong. And here's what you get. Here's what you get in some of these outcrops. Very poor quality, very vuggy, very weathered material, highly, and this was in a short distance from one another. So there's some nasty sort of material out there, and it's along that line where we just laid down this three-dimensional imaging data set that hopefully might show some of that extreme variability in his product.
Did you test those for velocity in the lab? I mean, even free test?
Yeah, right there, right there. This particular one was about 1,800 meters per second, and this particular one was about 4,800 meters per second. So these are just two examples. We've got, I don't remember the number anymore. We've got a whole stack of cores where we've done free resin column on all these cores from all over the site, actually.
Great.
This was just two examples.
Who paid for collecting those cores?
The deal you did? No. Taxes. FDOT. It was actually Universal Engineering's drilling contract came out and did those. but DOT, whatever you want to call that, us, right? Yeah, but it was part of the project we were working on, and they had this contract for doing drilling, and DOT sent them out, and we did all the CPT testing, all the coring at a number of these lines along there. So we also have some five cased boreholes down 50 feet well into the rock where we got all these cores and cased them later so we could do borehole techniques and a number of other things.
Do you have the report and all this with the result of that?
Sure. Well, there's
Is it an FDOT project?
these particular cores, I don't remember the report, but I know that there are several papers that Nick Hoodema has published that appear in various documents in which the data from this are available. Yeah. So they've been out there for, I don't remember. These tests were done probably 10 years ago. And
Actually, he has kept some of those codes there.
oh yeah,
He showed us in the lab.
yeah.
Last month.
Yeah, he's got a bunch of them because he's built a very nice rock mechanics lab over there at Jacksonville and has done all kinds of work. He's doing imaging work on all kinds of stuff. So we've got a lot of data on the materials from this site. Anyway,
You're going to be able to find cores from the donor